All the stars we see, including our Sun, are in a balance of powers. Stars are very heavy objects, so they have strong gravity, which presses them from the outside and makes them shrink. But inside a star, while it burns fuel, there are nuclear reactions that produce incredible amounts of energy. This energy is the light and heat that we feel during the day. But most importantly, these reactions increase the pressure inside the star and create a force that is fighting with gravity. So as long as the star has a full tank, it's safe. But then, the fuel runs out, the pressure inside the star falls, and the gravity wins. A star the size of our Sun can shine for about 10 billion years. Specifically, our lovely Sun is about 4.5 billion years old and has already burned half its fuel. The next stage in a star's life comes when it runs out of juice. Internal pressure drops, but gravity continues to press. At some point, a star simply collapses under its own weight and shrinks to the size of its core at the speed of almost a quarter of the speed of light. In less than half a second, a huge star turns into a small and dense object. This rapid collapse creates incredible shock waves that cause the upper layers of the star to explode. Now, an incredible amount of energy and matter is thrown into outer space. At this moment, luminosity of the star increases millions or even billions of times. This is the flash that our scientists can see with super powerful telescopes. But the light from this explosion doesn't reach our planet until many years later, so in fact, this star has long since faded. There are several options at this point. It all depends on the size of the star. If its mass is small, about the mass of our Sun, then for several months, this flash will become brighter and brighter until it reaches its peak. Then, the energy of the explosion will begin to dissipate, gradually fading and cooling down. A few years will pass, and the temperature of the former star will match that of space, and it will simply cease to exist. But the heavier the star, the more interesting the events will be. Heavy stars burn their fuel too quickly and have a much shorter lifespan. Stars weighing about 8 masses of the Sun can collapse into a rather unusual object, which is rarely found in the universe, a neutron star. This dull ball is only 6 to 12 miles wide and covered with a hard metal crust about half a mile thick. Neutron stars can weigh about 2 suns and have a strong gravity force. If you feel comfortable and in good shape on Earth, you wouldn't even be able to lift a needle or a match here. What's more, you would be pressed to the surface like a pancake and just unable to move. But there are stars dozens of times heavier than the Sun. An explosion of such a supernova, which weighs at least 40 times more than the Sun, gives birth to the most inexplicable and mysterious object in the universe, a black hole. At first, an incredibly bright explosion occurs. A shockwave spreads, carrying dust and matter of the former star around like a fog. And at the place of the explosion, only a small black disk is left. This black abyss is the heaviest object in the universe. It's so heavy that its gravity curves space-time around it. Yes, the closer you are to a black hole, the slower time will go for you. If you could get close enough to one of them, spend a couple of minutes in its orbit, and return to Earth, you would simply not recognize your home. 1 minute near a black hole can be a month, a year, or a decade on Earth. This depends on how heavy the black hole is. But don't get too close. The force of its gravity is so strong that even light can't escape from it. Humanity also knows about the existence of supermassive black holes. They gradually build up their mass, feeding on different cosmic objects just like a predator. Usually, such supermassive black holes lie in the centers of galaxies, and their gravity is so strong they can hold countless stars near them. For example, this is the only photo of a black hole, which is located in the center of the Messier 87 galaxy. The orange glow around it is its event horizon. That's the remains of the light from the objects this black hole has swallowed. You're quite safe though. The closest black hole is 1,120 light-years away. But supernovae can explode not only when gravity wins the fight with the star's internal forces. Sometimes the opposite happens. The nuclear fusion inside the star begins to affect much more matter than normal. The pressure inside a star increases, and it defeats the force of gravity that exerts pressure on the star from outside. At this point, there's a boom! This never happens by itself, and this type of supernova is only possible in binary star systems. Two stars are spinning around each other. One star begins to swallow the substance from the other. Then, the nuclear reactions inside it are no longer in balance, and a supernova explodes. For some time, scientists believed that such an explosion could occur in 2022. There's such a binary system in the Swan constellation at a distance of 1,800 light-years from the Sun. The luminous red nova should have occurred here. Such a red flash would have been visible to the naked eye for months. And after the explosion itself and the merger of two stars, a new, hotter, and heavier star was to appear in their place. But a new analysis of the data revealed a calculation error, and this event will not happen soon after all. So now we see that a supernova explosion is a very dangerous event, and it can cause great harm to our planet if it happens close enough. The main danger is gamma rays. This is the radiation that comes from the explosion. When these rays reach the Earth, they affect our space shield, the atmosphere. They reduce the ozone layer and make us vulnerable to solar radiation and cosmic rays. In this case, all life on the planet is in incredible danger. And the bad news is that such an explosion could happen quite soon. Betelgeuse, the brightest star in the night sky, about 17 times larger than the Sun and 8.5 billion years old. It's begun to exhaust its fuel reserves. Scientists predict that this giant will explode like a supernova at any moment within the next 10,000 years. So it may happen in a few centuries or even tomorrow. Everything will happen as follows. Betelgeuse will collapse in a fraction of a second, and then it will explode so brightly that it will look like a second moon in the night sky. We will observe a new bright spot in the sky for weeks or even months. But then, it will begin to fade until it completely disappears. Not without a trace though. In its place, there will be a neutron star, weighing 1.5 times the Sun. It will be one of the biggest events that humanity has ever seen. Still, we have nothing to be afraid of. Betelgeuse is about 550 light-years away from us, so its X-rays and ultraviolet light will not affect us. A much greater danger is posed by the release of material that occurs in a supernova explosion. But this shouldn't make you worried either. The shockwave won't reach the Earth until 6 million years later, and it will be suppressed by the oncoming solar wind. So if we see Betelgeuse explode today, it will be an epic sight. But in fact, the star will not exist at the time, because it will mean the event itself happened almost 6 centuries ago. It's just that now the light from it has reached us. Some scientists believe that the Ordovician Silurian extinction events, which occurred almost 500 million years ago, happened exactly because of a star explosion. Then, almost 60% of marine vertebrates went extinct. Yet, it was not a supernova, but a hypernova. That is what scientists call explosions of stars 100 to 150 times larger than the Sun. In addition to the abnormal weight, the star must rotate very quickly. Such objects are very rare. In our galaxy, there are few of them, and scientists believe that hypernovae occur about once in 200 million years.
For a few decades, scientists have been debating whether there's a mass gap between the heaviest neutron stars and the lightest black holes. And finally, for the first time ever, researchers have discovered an object with a mass falling right into this gap. It started on the 29th of May, 2023. The LIGO Livingston detector in Louisiana recorded a mysterious signal. It was produced in the process of a merger of a neutron star with an unknown compact object. It was most likely an unexpectedly lightweight black hole. Its mass could be just a few times that of our Sun. That's why this object falls into the lower mass gap between the lightest black holes and the most massive neutron stars. According to Einstein's theory of general relativity, neutron stars are likely to be lighter than 3 times the mass of our Sun. But the exact mass after which a neutron star will collapse into a black hole is still unknown. And considering our previous electromagnetic observations, we can expect to find very few black holes or neutron stars within the range of 3 to 5 solar masses. And still, the mass of one of the newly discovered objects perfectly aligns with this range. But let's have a better look at how the situation with the LIGO detector unfolded. Just 5 days after the launch of the 4th observing run, things became really exciting as the detector recorded a gravitational wave that was classified as signal candidate S2305529A. The online analysis was performed almost in real time as the signal arrived, and the conclusion was astounding. A neutron star and a black hole most likely merged around 650 million light-years away from our planet. Unfortunately, it's impossible to say exactly where the merger had occurred since only one gravitational wave detector was recording scientific data when the signal arrived. That's why the direction from which the gravitational waves came wasn't determined. And still, the researchers were sure that the signal wasn't some local disturbance in the LIGO Livingston detector. It actually came from deep space. To figure out the properties of the space bodies that orbited each other before merging and producing the gravitational wave signal, astronomers compared data from the LIGO Livingston detector with 2 waveform models. The detected signal appeared as a result of the merger of a compact object with 1.3 to 2.1 times the mass of the Sun, and another compact object with 2.6 to 4.7 times the Sun's mass. Were these compact objects a neutron star and a black hole? We can't tell for sure using gravitational wave analysis alone, but based on everything we've learned about the properties of this binary, astronomers think that the lighter object is a neutron star and the heavier is a black hole. Of all the neutron star-black hole mergers we've detected so far, the most recent one is also the one in which the masses of the 2 participating objects are the least different. Experts explain that if a black hole is way heavier than a neutron star, no matter will be left outside the black hole after the merger. No electromagnetic radiation will be emitted either. As for lighter black holes, they can rip neutron stars apart with their strong tidal forces. In the process, they eject matter that might glow as a kilonova or a gamma-ray burst. The detection of this interesting phenomenon became possible due to several improvements made to the detectors, which increased the sensitivity of the equipment. The highly successful 3rd observing round finished in spring 2020 and brought the number of known gravitational wave events to 90. The 4th observing round started in May 2023. Researchers at an institute in Hanover, together with their LIGO colleagues, have improved the laser sources of the LIGO detectors located at the heart of the instruments. Along with hardware, experts have also worked on other features of the detector. And now, these space exploration tools can figure out the properties of black holes within mere days.
Imagine you're looking up at the sky on a clear night, and you see all those beautiful stars twinkling up there. Well, one of them is Betelgeuse, a celebrity among stars. If you want to catch a glimpse of it, look up at the Orion constellation. It low-key looks like an archer holding a bow, and you can spot Betelgeuse as the reddish-orange dot on their shoulder. It's one of the brightest stars in the sky, so it's hard to miss. Betelgeuse is not your ordinary star. First of all, it's gigantic, up to 1,000 times the size of our sun. Can you imagine that? It's so enormous that if we could somehow replace our sun with Betelgeuse, it would engulf all the inner planets, including Earth. And here's another fun fact. When we look at Betelgeuse, we're actually looking back in time. Yep, you heard it right. Betelgeuse is about 600 light years away from us, so the light we see today actually left the star 600 years ago. It has quite a history. This star has been shining brightly for millions of years. Long, long ago, even before smartphones and telescopes, ancient Sumerians were the first to spot Betelgeuse in the sky, and it's been a diva this entire time. For example, in 1866, Betelgeuse became one of the brightest stars in the night sky. It was so dazzling that people could see it even during the day. Astronomers all around the world went bananas documenting this extraordinary event. Since then, Betelgeuse has been playing hide-and-seek with us. It all started when Betelgeuse started to dim back in 2019. Since then, it likes to dim and brighten sporadically. But these changes in brightness tell us about something important. As we mentioned, Betelgeuse was always a bit of a troublemaker. It's been living a fast and furious life. Because of that, it has been burning its fuel at an incredibly fast rate. The changes in the star's brightness are clues that Betelgeuse is approaching the end of its life cycle. The drama intensified when the Hubble Space Telescope snapped jaw-dropping images of Betelgeuse, like it was getting ready to blow its top. All this made scientists think that the star is close to retiring in a dramatic way. It's about to go supernova. So picture a star partying hard, powered by the fusion of hydrogen atoms. It's like the star's own energy drink. But just like any party, the fuel starts to run out. That's when things get interesting. As the star guzzles up its hydrogen fuel, it slowly begins to run on empty. It can't sustain itself anymore. So now, it's time for the grand finale. This finale is called supernova. The star collapses in on itself like a deflating balloon. The pressure and temperature inside skyrocket to mind-boggling levels, and this celestial tantrum triggers a colossal bang. So you can see why observing Betelgeuse is like having a front-row seat to the spectacular drama. But here's the big question. When will this happen? Well, the answer is not as simple as setting a timer. You see, stars have their own schedules, and Betelgeuse is no different. It could be tomorrow, or it could be thousands of years from now. Scientists have come up with only a rough estimate. They believe that Betelgeuse will go supernova within the next 100,000 years. Quite a spread, huh? Sure, that sounds like forever to us, tiny humans. But in the vastness of the universe, it's just a blink of an eye. But there's a chance, just a tiny chance, that Betelgeuse could surprise us all and go supernova much sooner. Considering its dips in brightness, we might be in for a show within the next few hundred years. We'll just have to wait and see. Now, if Betelgeuse does go kaboom, what will happen? Well, get ready for a show like no other, folks. When a star collapses under its own weight, it unleashes a cosmic firework of epic proportions. The star releases a crazy amount of energy in the form of light and heat. Betelgeuse's supernova is going to be extra special. It's like the superstar of supernovas. It will shine so brightly that it might even outshine the other stars in the sky. Picture that, Betelgeuse stealing the spotlight. The show could be so bright that you won't need a telescope to catch a glimpse. Nope, you'll be able to see it with a naked eye. It might even be visible during the day, making the sky look like it's hosting the coolest rave ever. After that, the supernova will keep us entertained for weeks. It will be like having a second moon in the sky, shining as bright as the full thing. Imagine that, 2 moons dancing together in the night. After several weeks of lighting up the night sky, Betelgeuse's supernova will slowly fade away, but it would leave behind a souvenir, an ethereal remnant. It's like a fading memory of the star's epic performance. This remnant, too, would slowly fade away over the course of several months. But it's not just about the light show. The boom will send out powerful shock waves, and we might actually feel them right here on Earth. It's like the universe giving us a gentle tap on the shoulder, saying, hey, look at this amazing spectacle. How dangerous will it be for us? Well, we know that Betelgeuse's supernova would send dust and gas shooting into the atmosphere. It's like a big space sneeze. And this sneeze could cause a decrease in global temperatures. We're talking serious climate impact here. It could even lead to a mini ice age. But these are just assumptions. We don't know for sure if the consequences will really be that serious. But, of course, we want to be prepared for this event just in case. That's why scientists are studying Betelgeuse closely. But, in addition to serious scientific research, astronomers also have a blast of celestial comedy. Jokes are flying left and right. Someone has even created a Betelgeuse status account, which you can check yourself. So, as you can see, the star is keeping us on our toes. Astronomers keep observing it, and they need our help too. They want us to keep an eye on Betelgeuse and report any changes we see. How do you do that? First off, channel your inner astronomer and observe Betelgeuse. Take a peek at the star and note down what you see. Is it twinkling, shining, or feeling a bit dim? Jot it all down. Then be a superstar yourself and report your observations to the astronomers. Your observations will help them track Betelgeuse's journey towards its big supernova moment. You can also join in on some citizen science projects. They're super fun and easy, trust me. One cool project you can jump into is the Betelgeuse Brightness Monitor. By participating, you help scientists keep tabs on how bright Betelgeuse is shining. Your contribution can make a real difference. So join the monitoring team. You'll be part of something amazing, and who knows? Your observations might even help predict when Betelgeuse will show off its supernova magic. By doing that, we can assist them in monitoring this superstar and learn more about the fascinating world of stars. But that's how we can help scientists to predict this event. Now, how can you personally prepare for it? First things first, you'll need the right gear to catch all the supernova action. A trusty telescope is like your front row ticket to the starry show. It'll bring you up close and personal with Betelgeuse's performance. And remember, you'll need special eyewear to shield your eyes from the intense burst of light. Safety first. And of course, prepare in case it decides to mess with our climate. Stock up on essentials, like warm clothes and supplies, just in case we experience a mini ice age. But let's just hope it won't happen. So keep your eyes on the night sky, my friends. Betelgeuse may not be ready to blow up just yet, but when it does, it will be a sight to behold. Until then, let's enjoy the twinkling stars. And remember, there's always something extraordinary happening in the vastness of space.
Now, it's been a long time since there was a supernova in the Milky Way. Over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the Southern Hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Carinae as the seventh brightest star in the constellation Carina, Eta being the seventh letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century, but modern studies of Eta Carinae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Carinae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Carinae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Carinae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Carinae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Carinae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Carinae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either 0 magnitude or negative magnitude. The full moon, for example, is magnitude negative 13. A magnitude positive 4.5 star, like Eta Carinae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Carinae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Carinae is really 2 stars, Eta Carinae A and Eta Carinae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Carinae C. Good guess. Blown out into 2 incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Carinae is, without a doubt, one of the strangest looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Carinae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Carinae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Carinae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean 2 things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close, because the eruption we saw in the year 2000 really happened 10,000 years before. Many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about 1 full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in the star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful, stellar neighborhood, except for those Martians next door. Castles were cold places in times past. The stone seemed to radiate the winter chill. This is one practical reason why tapestries were hung upon castle walls, to help keep the cold out and the warmth in. But you just can't hang any old thing on castle walls. It should be beautiful, heroic, with a heavy wow factor. The ancient Greeks hung tapestries on the walls of their castle of the sky, glorious tapestries woven of stars. All 48 constellations of the Northern Hemisphere were designed and named by the Greeks. The story of Andromeda is one such tapestry, woven of 7 constellations spread across the entire autumn sky. The story contains detailed astronomical observations preserved as highlights in the sky tapestry. It begins with the constellation Cassiopeia, queen of the oldest realm in Africa, Ethiopia. When the constellation Cassiopeia is on the horizon, it looks like a staircase going up to the Milky Way. Step pyramids around the world are often thought to have been inspired by the constellation Cassiopeia. In any case, Cassiopeia is a beautiful constellation, indicating that Queen Cassiopeia was also a beautiful woman. She was good-looking, but equally vain, which sets off all the dramatic action. Cassiopeia can be found in the night sky opposite Ursa Major from the North Star. Like Ursa Major, Cassiopeia circles the North Star and is a circumpolar constellation. A supernova was observed in Cassiopeia around 1680 Earth time, Cassiopeia A having occurred about 11,000 years earlier. The Chandra X-ray satellite recently recorded an extraordinary photograph of this supernova remnant, showing the elements sulfur, calcium, silicon, and iron amid the expanding cloud's high-intensity X-rays. Cassiopeia's husband is also a circumpolar constellation, a minor, dim one named Cepheus. He had his own kingdom. A merger of empires by way of marriage is something common throughout history. Cepheus was a king of Phoenicia. There were many kings of Phoenicia back in the days when Phoenicia was just a collection of city-states along the western shore of the Mediterranean Sea. Cepheus can be found in the area between Cassiopeia and the North Star. The constellation of Cepheus is important to astronomers. It's where Henrietta Swan Leavitt discovered variable stars that pulsed at regular intervals. The rate of pulsation of the star indicates the true brightness of the star and enables a sure measurement of the distance to the star. The discovery of Cepheid variable stars was a major breakthrough for early 20th century astronomy. Cepheus and Cassiopeia had a daughter, Andromeda, also a noted beauty, about whom all the fuss is. It seems that one day Cassiopeia was boasting about the beauty of her and her daughter Andromeda. "We are more beautiful than any other women in the whole wide world." Well, such pretension can be forgiven for a queen. But then Cassiopeia went further and stepped beyond all natural bounds. In fact, "We are more beautiful than any of the Nereids." Well, the Nereids were Greek mythological sea nymphs, daughters of the ocean. Noted for their beauty and kindness to sailors, the Nereids, all 50 of them, took offense at being dissed by a mere mortal woman. Cassiopeia had to be punished for exceeding the bounds of the civil order. By her excessive vanity, Cassiopeia transgressed beyond the bounds of nature, for which an unnatural punishment was inflicted upon the entire kingdom of Ethiopia. A monster from the bottom of the ocean, the constellation Cetus, began to devastate the coastal villages of Ethiopia as well as Ethiopia's fishing ships. Fittingly, Cetus is a constellation of the southern celestial hemisphere. The fourth largest by area of all the constellations, Cetus swims in a dark part of the sky called the ocean, with only its head rising above the celestial equator. This part of the sky contains several water-themed constellations: Pisces, the fishes, Aquarius, the water-bearer, and Eridanus, the river. Over 50 exoplanets have been discovered in Cetus. You can bet the James Webb Space Telescope will have a field day analyzing the spectra of these planets' atmospheres, looking for signs of life. Meanwhile, Queen Cassiopeia and King Cepheus must do something about the monster devastating the shores of Ethiopia. They consult an oracle and make another trespass beyond the realm of reason and nature. "Tell us, oracle, what can we do to stop the monster from ravaging our kingdom?" This monster is not a normal affliction of nature. An offense was committed against the higher realms, and this is the punishment. The monster cannot be stopped by any normal means. Only a human sacrifice of the noblest being may placate the beast. One error compounds another. The noblest person in the kingdom, of course, is Princess Andromeda. According to the command of her father and the consent, or perhaps a suggestion of her mother, Andromeda is chained to a rock offshore. She is the human sacrifice that her parents hope will save the kingdom. Wow. Da-da-da-da! Here comes the Greek hero to save the day, stop the human sacrifice, and turn Cetus to stone. Perseus. Now, where is Perseus coming from? According to legend, the Hebrides. Perseus went to the Hebrides in pursuit of the Gorgon Medusa. The geological scope of this tapestry is incredible, from the Hebrides to the Red Sea. The Hebrides are an archipelago of mostly rocky islands off the western coast of Scotland. It was impossible to sail any further. The Hebrides were the absolute end of the world. Perseus didn't have to sail to the Hebrides. However, he flew on a pair of winged sandals. Hey, way to go, Perseus! Now, Medusa was one of the all-time baddies. One look at Medusa was so terrifying it would petrify you, literally turn you to stone. Perseus was in great danger. So, what did our hero do? Instead of looking at Medusa, Perseus used the scientific principle of reflection. He slew Medusa by seeing her reflected in his polished shield. In our sky tapestry, Perseus is portrayed holding up the severed head of Medusa. In the night sky, one eye in Medusa's head opens and closes and opens again. Arabic astronomers named the star Algol, the ghoul. Algol is an eclipsing double star. One star is bright, the other one, not that much. As the dimmer star orbits the bright star, it passes in front of the bright star, eclipsing it, and the eye closes. Since the dim star takes 2 days, 20 hours, and 49 minutes to orbit the bright star, the eye in Medusa's head opens every day and a half or so. The constellation of Perseus is immediately below Cassiopeia, and skywatchers quickly look to see if Algol is eclipsed, if Medusa's eye is open or closed. Perseus flew back from the Hebrides, accompanied by Pegasus, the winged horse. The central part of Pegasus is the Great Square, made up of 4 stars. As Earth goes around the Sun, the Great Square is right in the center of the night sky in autumn. In the summer triangle of Vega, Deneb, and Altair are in the middle of the night sky. In spring, it's Leo the lion, and in winter, it's Orion the hunter. These are the walls of the castle in the sky, and all have marvelous tapestries adorning them. The constellation of Andromeda shares a star named Alpheratz with Pegasus. It's one of the corners of the Great Square, so it appears Andromeda may be riding on Pegasus. Her crown, remember she is a princess, is floating nearby. M31, the Andromeda Galaxy. To see M31, cross the corners of the Great Square from the lowest star to the uppermost star, and then go a little further to see the Andromeda Galaxy. Be sure to peek at it from the corner of your eyes. It's called averted vision. The corners of your eyes are more sensitive to light, so you'll be able to see the huge spiral galaxy 2.5 million light-years away as a smudge of light 1.5 times wider than the full moon. Now, Perseus doesn't go in for human sacrifice, so he stops it and saves Andromeda by exposing Cetus to Medusa's gaze. And here we encounter the second eclipsing variable in our sky tapestry, Mira, the heart star of Cetus, the sea monster. Mira, from which we get the English word mirror, so fitting in a story about vain beauty, is an eclipsing double star. The dim star orbiting the bright star is a white dwarf, not bright enough to see with the unaided eye. The effect is that Cetus's heart shuts off. Mira is eclipsed and disappears. This cycle repeats itself every 332 days. Our fabulous star tapestry has the only 2 eclipsing binary stars visible to unaided eyes, the nearest spiral galaxy, and a hero that doesn't like human sacrifice and uses the scientific principle of reflection to thwart mythological monsters. Wow, I would hang that in my castle too. Just saying.
What would the Earth look like if it was born in another solar system? I did a little research for you to find out, and the results were surprisingly wholesome. There are some warm tropics, strong winds, and giant dragonflies. But okay, let me explain from the very beginning. Since 1995, NASA has discovered more than 4,100 planets outside the solar system. Unfortunately, most of them are either flying ice balls like Neptune or gas giants like Jupiter. But there are still as many as 161 planets similar to our Earth. And one of them is very close to us, in the Alpha Centauri constellation. There are 3 stars in this constellation. 2 of them are called Alpha Centauri A and Alpha Centauri B. If you live in the southern hemisphere, you've probably seen them. They're very bright. Because of that, they look like one big star. They rotate around each other very slowly. And there's the third star, chilling around not far from them. It's a teeny tiny red dwarf, Proxima Centauri. It got its name because of its proximity to our Sun. This star is the most interesting one, so let's talk more about it. Proxima Centauri is only 4.5 light-years away from us. Oh, and 1 light-year is about 6 trillion miles. Yep. If we went there, it would have taken just a little over 165,000 years of traveling in a space shuttle. Oh, you think that's a lot? For the universe, it's like checking on your fridge. Proxima Centauri is much lighter and much smaller than the Sun. It's also 2 times colder than the Sun, with a temperature of 3,000 Kelvin. That's why we can't see it without a telescope. On the bright side though, it will burn for trillions of years, and you don't have to worry that one day it will eat us like our Sun. And yes, our twin planet is located right next to Proxima Centauri. This planet is called Proxima b. Yeah, I know, they got creative with all these names. I hope you won't get confused. It's slightly larger and more massive than the Earth. This planet is located in the habitable zone of Proxima Centauri. It means that there can be water and even some microorganisms there. Yes, it's possible that one day we'll find some life there. But right now, we don't know much about this mysterious planet. It's probably a rocky planet like our Earth and has a similar landscape, but this is just a theory. Who knows what kind of jokes the universe can throw at us? It would be a shame to fly 165,000 years just to stumble upon a giant piece of ice or something. Fortunately, we probably don't have to wait that long. The big brains are now developing a technology that would allow us to move at the speed close to the speed of light. If they succeed, we'll get to Proxima b in just 20 years. But anyway, this video is not just about Proxima b. It's about what would have happened if life had originated not in our solar system, but in Alpha Centauri. What if we were orbiting Proxima Centauri, or the other 2 stars? So now, let's imagine that the Earth has replaced Proxima b. I'm going to call this new planet New Earth. Guess I'm not very creative at naming either. First of all, the orbit. The new Earth must be about 25 times closer to its star than Proxima b is. Otherwise, it would be unimaginably cold. Let's move the planet a little closer. Excellent. The day still lasts 24 hours, but our orbital period is very high. Proxima b revolves around its star in 11 days. But we'll make it in just 8. Hey, a birthday party every week? Sign me up. Oh, hold on, there's another problem. You see, Proxima Centauri is a flare star. This means that sometimes, just out of nowhere, it throws out some stellar winds. These winds carry around a bunch of ionized particles, which then settle on the planets. Yeah, our Sun also does that, but Proxima Centauri tries to finish us off 2,000 times harder than our Sun, so the radiation levels are off the scale, to say the least. Don't worry, it's fine. All we need are incredibly strong magnetic fields. They will help us create a very thick atmosphere that can protect us from the Proxima Centauri's tantrums. So now it's going to be very warm, or not. Another problem. Scientists are still not sure how exactly Proxima Centauri's planets rotate around it. What if they turn out to be tidally locked, like our moon? Then one half of the new Earth will be a frying pan, and the other half will be some frosty deserts. Oh, it's fine, we'll just settle down somewhere in the middle. Didn't expect that I would ever say this, but it will definitely be warm at the North Pole. And if we're lucky with the rotation, we'll just get a cozy, warm planet. The average temperature is about 70 degrees Fahrenheit, and there aren't any extreme temperatures. On the new Earth, we have much more water. The weather is generally pretty crazy, some very strong winds and quite destructive rains that can go on for quite a long time, but you can adapt. Temperature changes are much more noticeable in the mountains. Just like on Earth, the higher you climb, the colder it gets, except it's very cold right here at the top. Because of this, the mountains and hills have jungles below and snow-covered deserts on the tops. But in general, it's almost like the Earth's tropics. The flora is very rich, the trees are very low but lush. The thick atmosphere also makes flying easier, so there are a lot of large flying animals, like dragonflies with a wingspan of 16 feet. Moving on. The sky here is much lighter than that on Earth and very cloudy. Sometimes it may seem completely white. But the starry night is beautiful and bright. There are 4 suns. Our main one is Proxima Centauri. We can also see 2 bright Alpha Centauri stars. And finally, our old sun, which looks like a bright, distant star. I'll allow you to shed a tear for the old Earth. There's a few planets near us, like Proxima Centauri c. The host star is surrounded by 2 belts of cosmic dust, so get ready for some gorgeous, colorful night views. So what we have in the end is a little crazy, but a beautiful green planet. I personally wouldn't mind moving there already. What about you? Write in the comments. Alright, so now we know what would have happened if our Earth had been born near Proxima Centauri. What about the other 2 stars? Unfortunately, we won't be able to rotate near 2 stars at the same time. Scientists suspect that Alpha Centauri A and B have some kind of common planet that jumps from one orbit to another, but it's probably very cold. Let's choose Alpha Centauri A. Just like on the new Earth, here our average temperatures are about 70 degrees Fahrenheit, but now the temperature variation is quite large. It goes from negative 100 degrees Fahrenheit at the South Pole to 113 degrees Fahrenheit at the equator. We'll be fine close to the north. The day is still 24 hours, and the orbital period is 1 year and 1 month. It's almost the same for the Alpha Centauri B, but the orbital period is about half a year. Other conditions are very similar to those on Earth. Changes in the seasons are almost not noticeable. The temperatures don't change much either. No matter where we settle down, the neighboring star will be clearly visible, but we probably won't see Proxima Centauri. And that's about it. Of course, all this assumes perfect conditions. Just like on Earth, one slightest change, whether it's a thin atmosphere or a bigger distance from the star, and it won't end well. We got really lucky with our Earth. But even so, the chances of finding a habitable planet are very high. Even with the tiniest possibility, there will be about 15 million planets in our universe that we can find life on.
When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers at Vanishing and Appearing Sources During a Century of Observations, or VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. But it's harder when hundreds of them vanished at the same time. Could it be that the data was wrong, or these stars were too faint to detect? Nope, they quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reached the point where they ended their lives. You can have the most massive stars of all, and we're talking about those that are way heavier than our sun, and they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months, and it's still visible even across hundreds of millions of light years. But that's the point. You see the traces, unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life, so it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit, they're cool though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully, we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually, they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too. And the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see but we know exists because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle. It's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. the light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity, we're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP-40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways: in binary star systems and when there's a single star. Binary stars are 2 stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP-40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP 4365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star. But there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the sun. That's why if you were standing on its surface at its closest approach to our star, the sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it actually becomes smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. DGSAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DGSAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the Moon's south pole are likely to be the frostiest place in the whole solar system. The craters' floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rye Sylvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long. But the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. Dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/1000th of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our Moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They're the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. And a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile-wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.
Stellar collisions occur about every 10,000 years and are an incredible spectacle, but they're only fascinating to watch when they happen tens and hundreds of light years away. If a star collides with our own sun, it will be a global cataclysm that will leave no chance of survival to anything. If it happens, it will most likely involve a rogue star. These are stars that aren't bound by gravity to any galaxy and move independently through space. And such a star has already paid a visit to our solar system. To be more precise, 2 stars. This is Scholz's star. It's a binary system consisting of a red dwarf, which weighs about 86 times as much as Jupiter, and a slightly smaller brown dwarf, which is 65 times heavier than Jupiter. About 70,000 years ago, these stars approached the boundary of our system, the Oort cloud. It's a kind of shield of comets and cosmic bodies that surrounds our solar system. Humanity was already around at the time and probably began spreading worldwide from Africa, and they could have witnessed a dim red light in the night sky. And even though Scholz's star flew by us at a distance of about 0.8 light years, its gravitational field strongly influenced the movement of different cosmic bodies. But what if such a star didn't pass by, but went straight to the center of our solar system, to the Sun? Scientists say this may happen in 1.3 million years. Meet Gliese 710. This star has 60% of the Sun's weight and moves steadily towards us. Like people 70,000 years ago, we will be able to see the light from this orange dwarf with the naked eye. First, Gliese 710 will approach our shield, the Oort cloud. The star's gravitational field will capture some meteorites and throw them in all directions. The number of meteorites falling down on Earth will probably increase tenfold then. After that, Gliese 710 will move on to the planets. It will consume them one by one, scattering their fragments all over the system. And while small meteorites wouldn't disturb us much, now we'll have a real threat on our hands. Planet shards the size of a meteorite that wiped dinosaurs off the face of the Earth will zoom straight at us. The star is getting closer and closer to the Sun, and if we somehow survive the falling fragments of our former neighbors, now Gliese 710 will have zoned in on us. Gravity and temperature will just tear the Earth apart. Still, this terrible sight will long since have had no onlookers. Humanity will have evacuated from the Earth long before, of course. Earth, Venus, Mercury. Gliese 710 has approached the Sun. The smaller star will orbit the big one, gradually closing in on it in a spiral. With time, the 2 stars will merge, and if their total weight exceeds a certain value, a disaster will occur. The temperature of the rogue star grows and nuclear reactions inside it accelerate. Little by little, the inner part of the star heats up to a critical temperature, and a supernova explodes. In a few seconds, all the substance of the star is scattered into space, and a powerful explosion will wipe out what's left of our solar system. But so far, Gliese 710 is 64 light years away from us, and there's still a chance it will change its route and pass by peacefully. And what if 2 more unusual stars collide with each other? This is a neutron star. It's very small, only about 12 miles wide, but its weight is comparable to that of the Sun. This ball is extremely heavy. A neutron star collision can generate one of the most mysterious phenomena in the universe. Two neutron stars fall into each other's gravitational field. As they move, they gradually approach each other in a spiral. And just as they almost meet, two different scenarios can unfold. If the weight of the two stars is relatively small, then after the collision, their combined weight gives life to a new neutron star. But if our participants are a little heavier, then when they collide, their weight exceeds the critical point, and this creates a magnetic field trillion times stronger than the Earth's. All this happens in just 1 or 2 milliseconds and is accompanied by a blindingly bright flash. This is a short gamma-ray burst. It's considered the brightest and most energetic electromagnetic event in the universe. A black disk appears at the collision site of the neutron stars. It's a black hole. Scientists believe this is one of the possible ways of its appearance. Black holes have so much weight that they warp the space and time around them. They have an incredible gravitational force. If something gets too close to a black hole, it's unlikely to ever leave it. Even the photons of light, the fastest particles in the universe, are unable to shake off the black hole's grip. By the way, an ultramassive black hole is at the center of our Milky Way galaxy. It can weigh millions and billions of times more than the Sun. Now we know how a black hole is born, but what happens if two black holes collide? Astronomers have already seen such an event. For about 7 billion years, two huge black holes were circling around each other, gradually getting closer. One had the weight of 66 suns, and the other had 85. At the moment of collision, the big black hole absorbed the smaller one and grew even larger. The new black monster weighed as much as 142 suns. During the collision, a huge amount of energy was released, equivalent to the mass of 9 suns. The energy gave the universe a hefty shake, and the vibration from the impact has only recently reached Earth's telescopes. But in 4.5 billion years, an even more significant collision will occur. Our entire Milky Way galaxy will collide with the Andromeda galaxy. Although Andromeda is 2.5 million light-years away from Earth, it's still our closest neighbor. Our universe is expanding, and there's movement inside it. Scientists have found that Andromeda is moving in our direction at a speed of 74 miles per second. So, in about 3 billion years, stars and hot gas of this galaxy will be visible to us with unaided eyes. Then it will crash into our own galaxy within 1 or 2 more billion years. The duo will move around each other like a yo-yo. They will approach one another and then pass by at a very close distance at an incredible speed. They will begin to move away from each other, but the force of gravity will bring them back. And then another collision will begin. But this time, they will form one giant galaxy called Milkomeda or Milkdromeda. It's hard to predict what will happen to us and our planet. In one scenario, we may not even notice the consequences of the collision. Despite the galaxies being full of stars and other celestial bodies, they still consist mostly of emptiness. Stars are really far away from each other. For example, if we imagine that our sun is the size of a coin, then the nearest star, Proxima Centauri, would be as far as the distance from Philadelphia to Detroit. That's about 450 miles. So there's lots of space between the stars and the galaxies. The second possible scenario is when our solar system is left alone in dark space. When galaxies collide and circle around each other, a lot of stars will be ejected as if from a catapult. Look at the merry-go-round in an amusement park. When it spins, the centrifugal force pushes the swings out. And if you unhook the swings while it's spinning, it will fly away really far. The same phenomenon occurs with many stars during galactic collisions, and our sun might be among them. In this case, we will hardly notice the difference. Life on Earth will continue at its usual pace. The only disadvantage is that our usual night sky will begin to disappear, and in time, it will turn into a black void. The last and most unlikely option is that our solar system will collide with another star. Well, in this case, all life on Earth will be doomed, just as if a star like Gliese 710 would crash into the sun.
There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And, of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would never have found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning and there was no end. It sounded pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Pienzas and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere. We just didn't notice it. In fact, at first, Pienzas and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to -455 degrees Fahrenheit with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So everything in our world is pretty calm and stable, except for one point. This cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error, it's right there. So what is this cold spot, and how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1. Cosmic texture. This idea was brought up at the end of 2007. Then scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2. The supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation. And there is one, perhaps the most bizarre of them all. Theory 3. A parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision. For quantum mechanics, such crazy theories are pretty common, but for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest, highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere. But unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analysis. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot. It just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory. It could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes. But we can't refute this either. Actually, we may never know the truth at all. But it's still interesting to strive for it.
13.8 billion years ago, a mysterious explosion happened in space. It was chaos, a time when the stars, planets, asteroids, the rest of the space bodies, and galaxies were born. It was the Big Bang, a theory we all know about. But no one knows for sure what happened, where the universe came from, and what was there before. Some even think the universe went through a cycle where it contracted and expanded several times. In 1991, a cosmologist from Stanford University named Andre Linde had submitted an article with the main idea that there was a possibility the universe had been created in a laboratory. His theory said there was a chance an advanced civilization somewhere out there had created our universe. This civilization has made an entirely new cosmos that later evolved its own planets, stars, and intelligent forms of life. 30 years later, many scientists take this theory pretty seriously. They even started talking about things that we, as a civilization, can do to get to such an advanced level. The theory says this advanced civilization decided to add technology that helped to create a new universe out of nothing. It happened through quantum tunneling. It's when an atom can appear on the opposite side of some barrier, even though it's supposed to be impossible, considering the laws of physics of our world. Like if you wanted to pass a tall wall, but you can't pass it with ladders or go around somewhere. Imagine you can just walk through it like a ghost. In our world, it's not possible, but a more advanced civilization perhaps can do it. Plus, they realized how they could create new universes. Right now, on the cosmic scale, we could be a Class C civilization. We don't know how to recreate some things. For example, conditions on the Earth for when our central star, the Sun, goes out. If we manage to become a Class B civilization, we'll learn to adjust conditions to be independent of the Sun. That means we might be able to learn how to live even without it. And if we level up and become Class A, we'll know how to recreate cosmic conditions and produce our own cosmos in our laboratories. We think of the world we live in through 3 dimensions of space: east, west, north, south, and up, down. There's also 1 dimension of time, which means we can distinguish past from future. A 5th dimension would represent 1 more extra dimension of space. The theory of its existence was first mentioned in the 1920s. It was inspired by the theory of gravity by Albert Einstein, who said space-time is warped by matter and energy. We can't perceive these 4 dimensions, but we see how an object moves and attribute it to gravity. And maybe there's some other force, like the electromagnetic force, that's more than 1,000 times stronger than gravity, that could explain things going on in that extra dimension of space. The 5th dimension is curved in a way we can't see it, but the idea about it was mentioned in a string theory. It considers the universe as really small strings of mass energy, not as particles. They vibrate in 10-dimensional space-time, considering 6 dimensions are rolled up way smaller than a single atom. That led to the picture of the universe as a 3D island that floats in 10-dimensional space-time. Also, the 5th dimension might be an excellent explanation to tell us more about dark matter. That's the invisible stuff with a mass, but we can't see it, nor can it interact with ordinary matter. And dark matter is 85% of all the matter in our universe. The universe can't be still. It's constantly in motion, either contracting or expanding. We used to think there were 100 billion galaxies, but it turns out there are more than 1 trillion. The galaxies are moving away from each other. This is what it means when scientists say the universe is expanding all the time. There are voids between galaxies that sometimes stretch millions and millions of light years across. They can seem empty, but they can also contain way more matter than we can find in galaxies. Still, stars usually can't be formed there because the matter between those areas has lower density. But there's still plenty of so-called intergalactic stars. A good example is the Virgo galaxy cluster, 10% of which are intergalactic stars. We don't know how exactly they got there, but there are 2 possible ways. 1. Stars can collide, merge, or pass close to another galaxy, which can kick it off from its parent galaxy. Option number 2. A supermassive black hole can accelerate a star to very high velocities if they have a close encounter, which can, again, make a star be expelled from its parent galaxy. If you could have a giant magnet, you could even pull something out from the vicinity of a black hole. That's possible if the magnetic field near a supermassive black hole is as strong as the black hole's gravitational field. But it doesn't work if we're talking about material that's already beyond the black hole's event horizon. That's a spot with a gravitational force so powerful, not even light can get away. You'd need to accelerate this material to the speed of light, at least, to get away. For that, you'd need an infinite amount of energy. But a magnet could help if something's heading toward the black hole but didn't get inside yet. When someone mentions a black hole, you might get a picture of some giant void in space. but the Milky Way is most likely full of thousands of smaller black holes that float around the galaxy. When a star comes to its end, it will destroy itself in a supernova explosion, which is a cataclysm of energy. In that explosion, the densities in the core will reach an intense enough state that nothing will be able to escape. At the same time, the major part of the star explodes outward, but a part of it collapses inward, creating a black hole. The bigger the star, the bigger the hole. The black hole then swallows everything that comes in its way, including other stars as well. When a star gets sucked up into the black hole, it's ripped apart because of the strong gravity inside the black hole. Some of its parts fall into the black hole, while others get ejected at incredibly high speeds. Some black holes might have been formed in a different way. The early stages of our universe were, to say the least, pretty chaotic. It had high temperatures and pressures, and was in a state that shaped the entire cosmos. Under the right conditions, any old gas patch may have shrunk itself to become a black hole. And they came in many different sizes, from something that weighs a couple of pounds to giant masses like thousands of suns, and those in between. They aren't really black. Black holes are areas with strong gravity, and no object can escape when it gets inside. They feed off electromagnetic radiation, such as light and space particles. Since they're consuming matter all the time, black holes give off a dark glow. The Earth is not that close to the inhospitable edge of the solar system. We're the 6th planet from it. Scientists made a pretty cool 3D map of our solar system where we can see what the edge looks like. It took them 13 years to design it. The boundary is called the outer heliosphere. It marks the area in space where the solar wind, which is the stream of charged particles our sun emits, gets deflected and draped back by the radiation coming from the empty region beyond our solar system. The inner layer of the heliosphere is where the sun and the planets have a rough shape of a sphere, while the outer layer is not that symmetrical. This asymmetry happens because our sun is moving through the galaxy and goes through friction with the radiation in front of it.
What occurs when a star depletes its energy reserves? Interestingly, it balloons to a magnitude many times its original dimension. This happens because, as the star's core exhausts its hydrogen supply, it begins to shrink due to its gravitational pull. Yet, hydrogen fusion still persists in its outer layers. As the core shrinks and heats up, the external layers also get warmer, leading to their expansion, enlarging the star's radius. As it expands, the star consumes everything in its path, even possibly its own orbiting planets. Although astronomers have observed stars on the brink of, or just after, consuming planets, witnessing this event in action remained elusive. However, a groundbreaking discovery by researchers from various institutions revealed a star in the act of devouring a planet. Astonishingly, this cosmic drama unfolded not in a distant galaxy, but within our very own Milky Way, a mere 12,000 light-years away. And the subscribe and like button is only a few centimeters away. Go ahead and click. Thank you. Astronomers observed an intense flare from a star, whose mass ranges between 0.8 and 1.5 times that of our Sun, located near the Aquila constellation, resembling an eagle. Its brightness skyrocketed to over 100 times its usual within just 10 days, before diminishing rapidly. Intriguingly, this initial fiery burst was succeeded by a cooler, prolonged signal. This unique sequence hints at one possibility. A nearby planet was devoured by the star. Which planet met this fiery end? Experts suggest it might have been a scorching world, weighing anywhere from 1 to 10 times that of Jupiter. Such celestial bodies are often referred to as hot Jupiters. These massive exoplanets, akin to our solar system's Jupiter, complete their orbit around their host stars in less than 10 days. This particular planet had been inching closer to the star over time until it was irresistibly drawn into the star's atmosphere and eventually into its core. This cosmic dining event took place roughly between 10,000 and 15,000 years ago, when the star had been shining for about 10 billion years. Despite its advanced age, the act of engulfing was shockingly swift, like a quick bite. This is in stark contrast to other hot Jupiters, which saw more of a gradual consumption by their stars. It's uncertain to the astronomers if this star has other planets in its orbit, possibly maintaining a safer radius. But even if such planets exist, it could be millennia before they end up on the star's menu. Regardless, with this newfound knowledge, astronomers are keen to spot more of these celestial feasts. One day, our very own planet and a chunk of our solar system will face a similar destiny. Everything familiar will vanish in the blink of an eye. But no need for immediate panic. This event is slated for about 5 billion years from now. That's the estimated timeline for the Sun to exhaust its fuel and swell immensely, consuming the inner planets, Mercury, Venus, Earth, and Mars. Should humanity have settled on another celestial body by then, they'd have front-row seats to this cosmic upheaval. The Sun's luminosity would spike dramatically, casting off matter into the cosmos, and potentially even consuming Earth in its fiery dance. This phase of the Sun's life will span about 10 million years. Once the core temperature reaches 100 million K, a helium flash will occur, initiating the thermonuclear fusion process that synthesizes carbon and oxygen from helium. With this newfound energy source, the Sun will shrink in size. After around 110 million years, when the helium reserves deplete, the Sun will undergo a tumultuous expansion of its outer layers, transforming into a red giant once again. This Sun phase will be marked by intense flare-ups, with its luminosity at times exceeding its current level by 5,200 times. This will result from previously untouched helium remnants entering the thermonuclear reaction. The Sun will remain in this state for about 20 million years. The Sun's mass is insufficient for it to end its evolution in a supernova explosion. After traversing the red giant phase, thermal pulsations will cause its outer shell to be stripped away, forming a planetary nebula. At the heart of this nebula, a white dwarf will remain, a remnant of the Sun's core. This object, incredibly hot and dense, will be comparable in size to Earth. Over countless millions and billions of years, our once radiant Sun will cool and dim. This life cycle is typical of low to mid-mass stars.
Bang. That's how it all started, around 13.8 billion years ago, and was figured out over the past 100 years. Everything we see in space today, planets, asteroids, comets, stars, it wasn't there at the beginning. In the 1920s, astronomers came up with the idea of how a long time ago, the universe was just a single point, an extremely hot, like trillions of degrees hot, compact, dense point that stretched and expanded unimaginably fast. Matter that started flying in all directions at the speed of light at one particular moment. The Big Bang was complete chaos, with teeny tiny particles that were mixed with energy and light. Yes, a total mess, but still, in the first minute after the Big Bang, the base for everything that would later appear was almost finished. It was hot only during this huge blast. As soon as the expansion started, the universe began to cool down, similar to when gas cools when you spray it from an aerosol can. During that process, part of the energy kind of froze out, just like the water freezes into ice. Here, pure energy got frozen and solidified into matter. 1 minute after the bang, the cooling thing was still going on, extremely fast and literally everywhere at once, since the universe really doesn't have edges. It wasn't just a compact dot anymore. The base for further expansion and all that's coming was being formed. Remember those tiny particles from that first boom stage of the universe? They started grouping together, which formed atoms of helium and hydrogen. It took about 3 minutes for most of the helium and all of the hydrogen in space to be made. These two are the most common elements and the basic materials that later formed the first galaxies and stars. Just because the base wasn't finished doesn't mean the creation of the universe stopped after those first couple of minutes. True, after that, no new elements were created for millions of years, which is why the initial version of the universe was entirely helium, hydrogen, and energy. But eventually, atoms began to slowly group together, which, after lots and lots of time, caused the creation of galaxies and stars. Clouds of helium and hydrogen grouped and turned into stars that had gravitational forces. Our Sun is also made of 3/4 hydrogen, while the rest is helium. 1/4? Yeah. At later stages, some other, heavier elements started to show up too, such as carbon, iron, oxygen, and so on. It wasn't all about chemical processes where new elements, stars, or planets kept coming. The whole universe has been expanding ever since the Big Bang. Researchers realized other galaxies are kind of moving away from ours. Guys, you need to stop doing that. How will we discover alien life out there if you keep running away all the time? And not just that. The farthest galaxies are actually moving quicker than the ones closer to our galaxy, the Milky Way. The universe is fabulous, unknown, mysterious, scary, and completely silent. Imagine yourself floating in your spacesuit somewhere above Earth. All you could actually hear is the sound of your own breathing, nothing from out there. Since there's no atmosphere, sound doesn't have a way to travel or be heard. Speaking of spacesuit, that thing costs around $12 million. I guess that means we'll have to wait up a little bit more to try that whole chilling in space thing. Mercury is the closest planet to the Sun, so you might think it's the hottest one too. And yet, Venus actually takes the title of the hottest planet in our solar system, with the surface baked by a temperature of 840 degrees Fahrenheit. Fair enough. Mercury doesn't have an atmosphere, which is in charge of regulating temperature, so it loses the race for the title of the hottie of the solar system. Venus also has pretty long days. Just one takes around 243 Earth days. Now that comes in handy for those people with pretty long to-do lists, who like to take it easy and slow. However, Venus orbits the Sun in 225 Earth days, which means 1 year there lasts 18 days less than a Venus day. You can have 2 birthdays in 1 day then? Well, 2 birthdays in a day could be one of the good sides, but the downside is that on Venus, it rains sulfuric acid and snows metal. Not so fun anymore, huh? The Earth is cool itself. Being 4.5 billion years old and the only known planet that supports life, it also has more trees than there are stars in the Milky Way. 3 trillion, while there are only 100 to 400 billion stars. We may have counted trees, but still, so little do we know about our ocean. Only 5% of it is explored, so we know less about it than about Mars or the Moon, whose surfaces have been fully mapped. It's funny how outer space is just 62 miles away from us, counting from above sea level on our planet. Seems so close, I sometimes go that distance just to have my breakfast. And yet, only 5% of the universe is visible from Earth. 68% of it is dark energy, while 27% is dark matter, which we can't see with a telescope. So close, yet so far. We will always see the same side of the Moon no matter where we are on Earth. The Moon rotates on its axis at the same speed it orbits the Earth. This is called synchronous rotation. Sunsets on Mars are blue. That happens because the fine dust on the red planet has the size perfect for blue light to efficiently penetrate the atmosphere of Mars. So the blue light scatters, after which it stays closer to the direction the Sun goes, unlike the light of other colors. The universe is full of wonders, and one of them is a planet made of diamonds. Yay! It's twice bigger than the Earth, and scientists believe it's mostly covered in diamond and graphite. Now to get there, you might probably need that $12 million spacesuit, together with a really expensive ship. But if, and that's the key word here, you manage to go there and back, you may even easily pay it off. Scientists also have some predictions as to the end of everything. Oh boy, ready for this? At its early stages, the whole universe was dense and compact, so it was really thick. But after around 400,000 years, it kept expanding, which made it more transparent. All of this encouraged releasing light we know today as the cosmic microwave background, or CMB. It's like if you turn your TV on an empty channel and switch off the cable, you'll see the static black and white dots moving on your screen. There's something like the CMB, and also an afterglow of all that energy that was released during the Big Bang. CMB is still here. Astronomers can see it through the microwave telescope. Expanding never actually stopped. The universe is still spreading every second at an unbelievable speed, causing all the objects in space to move away from each other all the time. How repelling! We know it because the sun from other galaxies appears redder than it's supposed to be. This is called redshift, and it happens when the source of light moves further from the one who's observing it. Then there's gravity. It attracts all objects in the universe to each other, which is the reason why planets keep orbiting the sun, or why our solar system orbits the center of the Milky Way. It's why we stay on the ground, while in space we'd float since there's no gravity up there. Having all this in mind, scientists got the idea that one day the universe will simply take the opposite direction and start shrinking back, which will be known as the Big Crunch. Whether this really happens depends on the type of our universe. If it's open, it'll keep expanding and nothing will ever stop it. But over time, as it's stretching, the density will become so low, galaxies won't be able to form new stars, and the existing ones will fade away. When space loses all the light and heat, life won't be possible. The universe will just remain as a cold beyond, which will keep spreading thinly into endless darkness. And then, Big Crunch or not, bang! It all disappears. Hey, good thing we have billions of years ahead of us, huh? Well, maybe you. I won't be around then. I'm going to retire.